So we've spent a lot of time talking about how a missile flies, how it gets from point A to point B. But the big question is, why are we sending it there at all? Okay, let's get into it. Because literally everything we've covered, the guidance, the propulsion, the whole shebang, it all exists for just one reason: to deliver the payload, the warhead. All right, here's our roadmap for this explainer. We're going to start with the warhead's core purpose, then we'll get into all the different types and designs. After that, we'll look at the smart triggers that set them off, called fuses, and we'll wrap it all up by talking about safety and doing a quick review.
So first up, let's really nail down the role of the warhead. It's pretty fundamental to the whole operation.
To put it simply, the warhead is the business end of the weapon. That's it. Every single other part, no matter how complex or powerful, is just a delivery service. Its only job is to get this one piece to the right place at the right time. The whole mission comes down to this.
I just love this analogy from the source material. It paints such a perfect picture, right? The guidance is the brain, doing all the thinking. The propulsion is the muscle, providing the power to move. But the warhead is the fist. It's what actually delivers the impact.
Okay, so let's move on and take a look at how these fists are actually designed, because this isn't a one-size-fits-all kind of deal. These things are highly specialized, incredibly engineered tools.
Before a warhead design even gets off the drawing board, it has to meet 4 really crucial standards. First, it's got to be interchangeable, so you can easily swap payloads on a missile. It has to be unbelievably durable to survive the insane G-forces of launch. It needs to be field-ready, meaning you can assemble it quickly, even in rough conditions. And of course, the big one, lethality. It has to be designed for maximum destructive effect on its intended target.
So, what are the options? You can kind of think of it like a menu, where each item is cooked up for a very specific task. You've got your anti-armor warheads for tanks, fragmentation for aircraft or personnel, blast and earth shock for buildings, runway penetrators for, runways, and incendiary types for starting huge fires. It's all about picking the right tool for the job.
Let's start with taking out something tough, like a tank. There are really 2 main ways to do it. The first is a shaped charge, which uses a super-focused jet of explosive energy. The second is what's called kinetic energy, which is basically a really, really fast and heavy dart that just punches through armor with sheer force.
Now, this analogy for the shaped charge is just perfect. Instead of a big, messy explosion, it focuses all its power into a tiny, white-hot jet of molten metal. And just like a high-pressure water cutter can slice through stone, this jet literally burns its way through solid steel armor. It's pretty incredible.
So what if your target isn't a heavily armored tank? What about so-called soft targets, like an aircraft or troops in the open? Well, for that, you use a fragmentation warhead. Think of it as a bomb wrapped in a metal case that's designed to shatter into thousands of little razor-sharp projectiles, all flying outwards at something like 2,000 meters per second. Absolutely lethal.
For big structures, like buildings or concrete bunkers, you need a different kind of punch. A blast warhead creates a massive wave of pressure that can knock down walls. An earth shock warhead sends tremors through the ground to take out foundations. And a runway penetrator, that one's a 2-stage attack. It first uses its own momentum to burrow deep into the concrete, then it explodes to leave a massive crater.
And finally, there are incendiary warheads. Their purpose is, it's pretty straightforward. Start fires. They're designed for targets where a fire is the most effective weapon you can use, like fuel storage facilities or ammunition depots.
Okay, so we've covered the what of the warhead. Now it's time to talk about the when. A warhead is totally useless if it doesn't go off at the absolute perfect moment. And that crucial job falls to a little component called the fuse.
The most important thing to get here is that the fuse is the brain of the explosion. It's not just a simple on-off switch. It's an intelligent device designed to sense the single best microsecond to detonate the warhead to cause the most damage. It makes the final call.
Now, fuses generally come in 2 main flavors. You've got your simple impact fuse. It goes off when it hits something solid, perfect for a missile hitting a tank. But what if a direct hit is really hard, like against the fighter jet? That's where the proximity fuse comes in. It's like a tiny radar that sends out a signal and waits for it to bounce back. When the reflection says it's close enough, boom.
Then you've also got the altitude fuse. This one is designed to detonate at a very specific height above the ground. It uses things like barometric pressure or a little radio altimeter to know exactly how high it is. This makes it perfect for targets that are spread out over a wide area.
All right, in our last section, let's bring it all home. We'll look at the absolutely vital safety features that protect the operators, and then we'll do a quick review of some key comparisons.
Safety here is everything. To protect the people operating these systems, every missile has multiple safety locks. The fuse stays completely inactive or unarmed until the missile is a safe distance away from the launch site. It only fully arms itself just moments before it's supposed to hit the target. And if it misses, it's designed to self-destruct, preventing the warhead from falling into the wrong hands or causing unintended damage.
Now, this table is great because it lays out the two anti-armor methods we talked about side by side. You can really see the difference in philosophy, right? The shaped charge uses a chemical reaction to melt its way through armor. The kinetic energy penetrator uses pure brute force velocity to punch its way through. Just two totally different ways to solve the same problem.
And this chart does a brilliant job of showing you how to match the right fuse to the right target. Need to hit a solid object like a bunker? Impact fuse. Dealing with a large, spread-out target? Altitude fuse. Trying to take down a fast-moving aircraft where a direct hit is a long shot? The proximity fuse is your go-to. Okay, for anyone studying this, the source material gives a fantastic little trick to remember how a shaped charge works. Let's do this together. It takes 30 seconds. First, draw a rectangle with a U shape inside it. That's your metal liner. Step 2, fill in the space behind that U and label it high explosive. Step 3, put a dot at the very back. That's your fuse. And finally, step 4, draw a sharp arrow shooting out from the open end of the U. That's your high-velocity molten jet. See? Simple. So let's do a super fast recap. What are the key takeaways? First, warheads have to be tough and swappable. Second, they're classified by their job, anti-armor, frag, blast, and so on. Third, the fuse is the intelligent trigger, and it can be set off by impact, altitude, or proximity. And finally, safety protocols are absolutely non-negotiable to protect the troops.
So, I'll leave you with this final thought experiment to kind of tie everything together. Based on everything we've just gone over, if your job is to take out a fast, agile jet, and a direct hit is going to be tough, which warhead and which fuse would you choose to give yourself the best possible chance of success? Something to think about. Thanks for tuning into this explainer.